say diagonals have same midpoint, therefore parallelogram. Then you're not done because you got to show that this is a rhombus. Well, a rhombus diagonals should be perpendicular. So I'm going to go ahead and show that these two diagonals are perpendicular. Looking at their slopes. So down here, the slope of this red diagonal, notice how this is a capital print M and this is a lowercase cursive m. This means midpoint, this means slope. So I know I can see that it is a positive slope. The numerator, the top number is my change in y, so it goes from a -4 to a +5, so that's a +9, and then it goes from a -3 to a +2, so that's a +5. I can't simplify that, so I'm going to move on to my next slope, the other diagonal. So lowercase m is equal to slope of this diagonal. My rise, my change in y, I go from 3 to a -2, so it's a -5. I can clearly see that it is negative. And then my change in x, my run, my denominator, is -5 to a +4, so it's a change in 9. So I can see that the diagonal in blue ink has a slope of -5/9, and then the red has a +9/5. So those are negative reciprocals of each other. And so you would write to me, diagonals are perpendicular, therefore rhombus. So we've shown that this is a rhombus. Now, if this was a determine what's the best shape and you were given all 4 vertices, we had to find 2/5, but let's just say for fun that you were given that this was 2/5 and you were trying to identify, you didn't know that it was a rhombus, you would have to keep exploring this shape because this shape happens to be a square as well. So if you wanted to continue with this whole diagonals theme, we'd have to show that this rhombus is also a rectangle, and you could do that by determining that the lengths of the diagonals are the same, proving that diagonals are congruent. So you've shown that it was a parallelogram because diagonals bisect each other. You've shown that it was a rhombus because diagonals are perpendicular, and then you could show that it's a rectangle because the diagonals are congruent. So if it's all 3 of those shapes, it must be a square. So, alright, sweet. Moving on to our last one. I'm going to go ahead and erase this stuff so I have my graph, the full graph. So we're given these 3 points. I'm going to go ahead and connect them. Now, I know to connect these two because I can see that these form a 90-degree angle. It forms a right angle, so it's pretty obvious that these must be the 2 sides. But if you didn't see that, or if it's not as obvious on the test, then what you need to do for this is draw dashed lines for the 3 possible side lengths. These are the 3 possible side lengths for this rectangle. And what you need to do is, rather than finding the distance of those to see which ones are congruent, you would need to be able to identify which pair of consecutive sides have negative reciprocals as slopes. Their slopes are negative reciprocals. So if it wasn't that obvious on a test where to connect the dots, then find the slope of all possible sides. So here, the slope of this side, the change in y is a +6, and the change in, I'm sorry, I'm having difficulty reading this. It goes from -3 to 1. Okay, so -3 to 1, so that is 4. So this is 3 halves, positive 3 halves. This one's going to be a negative slope. I go from 4 down to 2, so that's minus 2. And then I go from negative 2 to 1, so that's 3. So again, I can see quickly that these two have negative reciprocals as slopes. So yes, those are the two sides, but just for fun, let's find this slope. I'm sure you guys think it's a lot of fun. We go from a negative 4 to a positive 4, so that's a change in 8. Then I go from negative 3 to negative 2, so that's a positive 1. So obviously I can see that this segment here can't be one of the sides of the rectangle because the consecutive sides need to be perpendicular, forming right angles. So now that I've identified what the two sides are given, I can then see that this fourth vertex needs to be out here to complete this shape. Once you have where it needs to be, you're just going to take the same method that we did over here and create those congruent triangles and just replicate how you're getting from this point to this point. Do the exact same thing to go from this point to that point. So in order, how I'm getting from this point to this one, I'm going down from 2 to a negative 4, so that's going down 1, 2, 3, 4, 5, 6 units. I'm going down 6 units, and then I'm going to the left 1, 2, 3, 4 units. So I need to do the exact same thing over here. So to get from this point to this point down here, I'm going to go down 6 units. 1, 2, 3, 4, 5, 6, and then go to the left 4 units. 1, 2, 3, and 4. So there is my point. It is at negative 6, negative 2. Please don't forget to tell me. You got to do more than graph it. You got to tell me where it is. And then now you need to prove that this truly is a rectangle. So there's many ways to go about that. First, show that it's a parallelogram, and then show that all of the consecutive sides are perpendicular. Since we already got my slope of these two sides, I'm just going to keep rocking that method. I'm going to find the slope between these 2 points. It goes from negative 2 to a positive 4, so that's a change in 6, and then a negative 6 to a negative 2, so that's a positive 4. So it gives me that 3 halves. And then this slope over here, I go up 1, 2, so that's the change in y, and then I go to the left 1, 2, 3, and that's a negative. So I know that this is a negative 2/3. So I've got all my slopes, so I can say that it's a parallelogram because both pairs of opposite sides are parallel. And then further analyzing your slopes, you can identify that this has to also be a rectangle because consecutive sides are perpendicular, forming your 4 right angles. And again, you would need to write that out to me and say that both pairs of opposite sides parallel, therefore parallelogram, and then all consecutive sides perpendicular, negative reciprocals, therefore rectangle. So I apologize for my sloppy handwriting, but so there it is. There is proving what shape it is, and then also or proving what quadrilateral it is, and then also finding that fourth vertex. So I hope this helps, and I will see you in class. I care about you more than you know.